This is a KS0108 GLCD display being operated by an MSP G2553 Ti microprocessor and being controlled by a Sony remote control. I chose the Sony remote control because it sends 12 data bits instead of the NEC remote that sent 32 data bits. It was easier to decode the information in the short amount of time between screen updates. On the proto board to the left, we got the MSP G2553 microcontroller chip, and to the right of it are two shift registers, and they are 74HC595 registers. They're TTL voltage shift registers, but with the MSP 430 running at above 3.2 volts, they read the high and the low signals just fine, so there's no need for a level converter. On the far right is a infrared receiver receiving a 38 to 40 kilohertz signal. On the left you see the LED that's used for current stabilization, and stepping from 5 volts down to the MSP 430's 3.5 volt power, I needed to regulate the current, and the LED helps stabilize it. I used a bipolar junction transistor and a pot to give me the voltage control, and it's pretty stable. I have battery backup with a blocking diode to prevent back charging, and the system will normally run with the MSP 430 running at about 3.3 volts. With the MSP 430 not running, it goes up to about 3.55. The fuse is for safety's sake. I had a previous clock with its own switching power supply that melted down because I didn't have a fuse with the power transistor unsoldering itself. So now I fuse my experiments at about a half an amp, and in reality the whole system draws about 50 milliamps, so it doesn't draw much power at all. On the back of the proto board you can see my not so fantastic soldering skills. Just anything that kind of holds a joint together. I have a lot of issue soldering joints 1/10 of an inch apart with the standard soldering iron, but for the most part it went alright. The big daughter board on the bottom left is from an emergency siren, and I adapted it to run with this board. It's a little tricky because it receives a signal voltage to turn it on, and to shut it back off it needs the same signal voltage applied for 3 seconds. So that made programming a little bit interesting. This is the clock in nighttime mode. Between 8 p.m. and 6 a.m. the background goes dark with the letters being brightly lit. From 6 a.m. to 8 p.m. the background is bright and the letters are darkly lit. This is so the clock puts out less light at night and doesn't disturb me in my sleep. The clock supports military time as well as standard AM/PM.